talk about voltage, current and resistance. Electricity is the movement of electrons. Electrons are charged particles. The movement of these charged particles can be harnessed to do work. Your light bulb, your mobile phone, your TV, your computer, all are harnessing the movement of the electrons in order to do work. They all are operate using the same basic power source, the movement of electrons. When we talk about electricity, there are three fundamental terms we need to understand: voltage, current and resistance. Voltage is the difference in charge between 2 points. Current is the rate at which charges are flowing. Resistance is material's tendency to resist the flow of charges, also known as current. When we are describing these terms, a common analogy is a water tank. In the water tank analogy, water represents the charges, water pressure represents the voltage, the control valve represents the resistance. Let's open the valve a little bit. Water starts to flow. According to our analogy, this moving water represents the moving electrons. Moving electron flow is named as an electric current. Let's open the valve furthermore. We are reducing the resistance. This allows to flow more electrons, a high current. Okay, now let's close the valve a little bit. The water is still moving. That means electrons are moving. We are increasing the resistance. It reduces the water flow, also known as electron flow. Increase of resistance causes decrease of current. Let's pay attention to the pressure. I am using the word voltage to the pressure. Forget about the valve or resistance now. If we increase the voltage, it causes an increase in the speed of water flow. The amount of water flow in a second is higher than earlier. That means increasing the voltage also increases the current. If we decrease the water pressure, it causes to decrease the speed of water flow. The amount of water flow in a second is lower than earlier. That means decreasing voltage also decreases the current. That's the water tank analogy for electricity. Water represents the electrons. Pressure represents the voltage. Control valve represents the resistance. And finally, the water flow represents the electric current. If we are closing the control valve, the water flow is decreased. In the same way, increasing the resistance causes to decrease the current. If we are opening the control valve, the water flow is increased. In the same way, decreasing the resistance causes to increase the current. Let's look into the pressure again. If we are increasing the water pressure, the water flow is increased. In the same way, increasing the voltage causes to increase the current. If we reduce the water pressure, the water flow is decreased. In the same way, decreasing the voltage causes to decrease the current. Current is the rate at which charge is flowing. Current is measured in amperes. An ampere is defined as 1 coulomb of electrons per second passing through a point in a circuit. Voltage is the difference in charge between 2 points. Voltage is measured in volts. Voltage is represented in equations and schematic by the letter V. Voltage is the pressure from an electrical circuit's power source that pushes charged electrons through a conducting loop, enabling them to do work. Resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, symbolized by the Greek letter omega. All materials resist current flow to some degrees. They fall into one of the two board categories, conductors and insulators. Welcome to Professor Mad, Electronics for Beginners. Today we are going to learn about resistors. We know electrical resistance is opposition to the flow of current in an electric circuit. The resistor's resistance limits the flow of electrons through a circuit. This is a conductor. Assume it has zero resistance. If we apply a voltage difference, then the electrons start to move through the conductor. A moving electron flow is a negative current flow. We can measure the amount of current using an ammeter. Here we have very high current because the conductor has no resistance to slow down the electrons. They move at full speed. Let's consider another conductor, but it has a resistor. Let's apply the same amount of voltage like the first one. Electrons start to flow. But electrons have no other option. They have to go through the resistor. Let's look at the ammeter reading. It's less than the first reading. Because the resistor limits the electron flow. Let's try another conductor that has two resistors in series. Current flow has to pass both obstacles. So the ammeter reading is lesser than earlier. Likewise, we can add more resistors in series and increase the resistance. This is the symbol of resistor. The total resistance is now R1. If we add another resistor that has R2 resistance, the total resistance becomes R1 plus R2. Let's add another R3 resistor in series. The total resistance increases furthermore. Now the total resistance is R1 plus R2 plus R3. So in general, the total resistance of the series resistors are equal to the sum of individual resistance. Let's go back again. We know series resistors reduce the current. Assume this resistor only allows I1 current to go through it. Now the ammeter reading is I1. What happens if we connect two resistors that has same resistance in parallel and apply the same voltage across those? Each resistor allows I1 current to go through it. Now the ammeter reading is equal to I1 plus I1, that is 2I1. You see, the current has increased. That means the total resistance has decreased. Using parallel resistors, we can reduce the resistance. Look at this circuit. V, R and I are the voltage, resistance and current between points A and B. If we add an R1 resistor between point A and B, it will pass I1 current through it. Current has no other way to go from A to B. So, the total current is equal to I1. Using the Ohm's law, we can replace the current by using voltage and resistance. Now we can remove the term voltage from both sides. We are getting an equation like this. Right. Let's add another resistor parallel to the R1 like this. This new R2 resistance allows I2 current to pass it. Now the current has two ways to go from A to B. So the total current is equal to the sum of these two currents, I1 plus I2. We can replace the I using Ohm's law and simplify the equation like this. We can keep adding resistors and continue this for more parallel resistors. For 3 parallel resistors, we can build an equation like this. In a parallel resistor circuit, the inverse of the total resistance is equal to the sum of inverse of each individual resistor.